Hi, welcome to the Calculus 3 assignment practice series. And we are in the unit of the vector calculus. So for this video, we're going to take a look at the homework assignment number 8. It's about the parametric surfaces here. We're going to take a look at a few problems and practice a few problems. And hopefully it will be helpful for you to work on the worksheets here. All right, so let's go to our worksheets and take a look at what type of the problems we have here. Okay, so for the first ones here, we'll talk about, okay, so want to determine whether the points P and Q are lies on the given surface here. Remember the RUVs, right? This is, so this is the one we use to parameterize the surfaces here. Okay, so now let's check the first one. Okay, so let's check the point 4, 5, -1, 4, -5, 1 to see is in the surface or not. Okay, so 4, what's that mean? That means x equal to 4, right? So that means u plus v equal to 4. And then the u minus what? 2v equal to what? To the y's, right? It's -5. And what is the other one? So 3 plus u minus v equal to what? Equal to 1 here, okay? So right now we can say, okay, so what do we need to do next here is we are solving the equations. So we are solving these two equations here, right? So when you solve these two, you will get, you solve the system of equation with two variables. So this one will give you v is equal to 3 and u is equal to 1 here, okay? So after you solve these two, then you plug this solution to see this one work or not, right? So when the u equal to 1, so this is 3 plus 1 minus 3 equal to 1. Oh, yes, that's good, right? So they all satisfy, so that's why we said, okay, so I know the pointer P is 4, -5 is on the surfaces here, is on the given surfaces here, right? And this surfaces is parameterized by this RUV. Okay, so now let's check the second points here, the Q here. So Q is 0, 4, 6. All right, so we do the same thing. So we say U plus V equal to what? U plus V equal to 0. And then the U minus 2V is equal to what? U minus 2V will be equal to 4. And then we have 3 plus U minus V is equal to what here? We have the 6 here, right? Okay, so now we do the same things here. We'll try to solving these two equations. Okay, so let's see when these two equations, when we try to solve it, and so I will have U is equal to 4 over 3, and V is equal to -4 over 3. Okay, so let's check. So the U is equal to the -4 over 3 here. Okay, so now let's take a look. I substitute these ones here to these equations here, right? So I will say 3 plus 4 over 3 minus, right? So this is minus -4 over 3. So this will be equal to the 3 plus 3 over 8. So it's what? It's 17 over 3, which is not equal to 6 here, okay? So because it's a, you know, if it has to, then all this has to satisfy these parametric equations, right? So I know what is your conclusions here. So I know the Q, point Q 046 is not on the surface, okay? Right, so it's pretty simple. Okay, so now let's go to the next problem I want to take a look. It's problem number 3 here. So we said, hey, I want to identify what is the surface. So for the given vector equation, that means what type of the surface will be if I try to parametrize, use this RUVs here. Okay, so we know these ones here. That means this is X, this is Y, and this is what? This is Z, right? Okay, so now I can say that X equal to the U plus V, right? Then Y equal to the 3 minus V. And Z is equal to the 1 plus 4U plus 5V here. Okay, so now let's do this here. So let's take a look at these ones here, these two, X and Y here. Okay, so if I combined it, so I would say the X plus Y, because V and negative V will cancel. So what is I have here? I have a U plus 3. Correct? Okay, so U plus 3, then I can say U is equal to the X plus Y minus 3 here. And because Y equal to 3 minus V, so I know V is equal to 3 minus Y here from the second equation, right? So now I can, you know, so now both this one I change to the U and the V. So what I can do here, I can substitute to my third ones here. So now I can say Z equal to 1 plus 4 is what here is X plus Y minus 3 plus 5V. V is what? 3 minus Y here, right? So what we will have here, so, you know, we simplify this is 1 plus 4x plus 4y minus 12 plus 15 minus 5y here. All right. So the 4x, so here I would say z is equal to 4x minus y, then negative 12, 15, 3, so it's plus 4, right? So it's a plus 4. So I can rewrite these ones here. So this is just 4x minus y minus z equal to the negative 4. So what is this surface here? This surface is a plane, right? All right. Okay, so that is how do we identify how, you know, what type of the surfaces given by these parametric equations here. Okay, so the next problem I want to take a look is number 19 here. So the number 19 is talk about, okay, so say find the parametric representation of the surfaces here. So they give you a surface, now they want you to find a, you know, parametric equation. So we say this is the plane and it goes through the origin, okay, so it goes through the origin and has the vector I minus j and j minus k here. Okay, okay, so because it goes through the origins here, so let's take a look here, right? So I have a vector a here. So vector a, I can say is I minus j, right? So I is what? It's 1, 0, 0. What is it? J is here, 0, 1, 0, right? So this one's here. This will be 1, negative 1, 0, correct? All right. And then the B's here, we say is J minus K. So we know the J minus K This one would be the 0, 1, negative 1. Now I can define, so because I'm going to find the u and the v, so I said, okay, this will just be combined u and v's in the vector. So I can say that my r, u, v, I can say here because it is goes through the origins, right? So I can say this one's here will be goes through the origins. Here I say the 0, 0, 0, all right? Then I say plus, you know, the vector A is here. This is 1, negative 1, 0. And what is here? Times the value of the u, then plus here, this will be 0, 1, negative 1 times the value of the v's here. So if you combine here, so now what is your final vector form going to be? Will be the u, then this is minus v, so u, this is v minus u, and so this is the negative v, right? All right, so this will be how did you find the parametric representation of the surfaces here. All right, so it's a pretty easy sections, right? So the last problem I like to take a look, it will be the number 36. So if my parametrics representation is sine u and cosine u, sine v, and sine v, and at the point u and v is pi over 6 here. Okay, so we want to find the tangent planes, right? Okay, so we want to find the, so this is the one we want to find the equation of the tangent planes. So here, okay, good. So remember, we want to find the tangent plane. What is the first thing? So we need to find the partial, right? So partial for u. So let's take a look. What is the partial for u? See here, the partial for u, sine derivative will be cosine. Okay, so cosine derivative will be negative sine u, sine v. Now, sine v, there's no u, so it's 0, right? Okay, very good. Then we take the partial for the v's here. Partial for the v, first term is sine u, have no v, is 0. Then the second term is sine v, so I know the sine v become cosine v, right? Then the next things here, this one will be what? Cosine v also, okay? So now I have the partial, then I know the normal vector will just be the RU cross RV. So we will do the same things here, like we have I, J, K, then you put it as a cosine U, then negative sine U, sine V, and 0. All right, so I need to put a K a little bit over here. So I have a place here. Then the RV is 0. This is a cosine U, cosine V. Then this is a cosine V's, right? Cosine V's here. Okay, so that's what this one's here will be cosine V's here. Then you can do the same thing like we do the cross product. And then we find it here. So I already did that. So I trust you can do the cross product. So it will be the square root of the 3 over 2, the I minus 1/2 of the what j plus k. Right, so my normal vector is square root of the 3 over 2, negative 1/2, and the 1. Okay, now because u and v is pi over 6, so what is my x? X equal to the sine u, so it's sine pi over 6, so it's 1/2. And the y is equal to the cosine pi over 6, sine pi over 6. So it's 1/2 times so it's a cosine u, cosine v. So cosine is what? Cosine is the square root of the 3 times over, and what is here? So here it will be times 1/2, right? So it's the square root of the 3/4. Now, what is z here? Z is sine pi/6. So what is sine pi/6 here? Sine pi/6 is equal to 1/2 here. So I know these things transfer the point to 1/2 square root of 3/4 and 1/2. Now the tangent plane is here, right? The tangent plane will be square root of the 3/2 x minus 1/2 and plus minus 1/2 y minus square root of the 3/4, and then plus here is z minus what? 1/2 is equal to 0s here. All right. So if you want to simplify, you can simplify it, or you can just leave it at this forms here. Okay, that's it. So this homework assignment is pretty simple, right? So we need to know how to find the parametric representations, and if the problem given the parametric presentation, how to find what type of the surface. And then also we need to know how to find the tangent plane of the surfaces at the given points here. All right. All right, that's it. I hope that the problem we did will help you try to finish the remaining of the problems here. Okay, nice talk to you, and looking forward to talk to you in our next videos here. Okay, bye-bye.